Hello, everyone. Welcome to the first ever Goldsmiths Computing lockdown lecture. And I can see loads of you saying hello in the chats. Hello, Andrea, Charlotte, Aquafic, Assad, Laverne, Tyrick, uh, Christina, who's going to be featured in this talk, and the Jedi Luke Skywalker. Awesome. Sort of celebrity Jedis even in the stream. Wonderful. So, my name is Marco Gillies. I'm a reader in computing at Goldsmiths, and I'm here to give the first of our lockdown lectures. So we thought this is a good way when everybody's staying at home and not able to get out to keep in touch with people, both from our own students to people who are maybe applying to study at Goldsmiths, to students on our University of London programs, and just anybody who's interested in what we're doing. I've been at Goldsmiths for 12 years now, and I teach lots of things. You may, if you're on the University of London online programs or looked at the MOOCs, I've done several MOOCs. You may see me teaching introductory computer science. That's the course I'm teaching at the moment. But I also teach quite a lot about virtual reality, and we have an online MOOC on that. We'll have a master's on that, and also I'm preparing a course for the BSc Computer Science on that. So my talk is going to be mostly about virtual reality, but it's going to feature some of the stuff I talk about AI in our computer science course. This talk is entitled Virtual Reality and Artificial Intelligence, and I'm going to be talking about some of the work I've been doing over many years to look at how artificial intelligence can be applied to make virtual reality. So it's the application of various AI techniques, particularly machine learning techniques, to virtual reality. So I want to get started, and I'm going to use my slides to talk about, I guess the first two questions are, what is VR and what is AI? So let's start with what is VR. Oops, that was the wrong button. So this is, and I can see she's on the stream. This is Christina, who's doing a PhD, a fantastic student at Goldsmiths in VR. And I think I really like this picture because it exemplifies a lot of what VR is about. Most obviously, she's got a headset on, so she's getting visual inputs that are completely surrounding her, and also you'll note headphones, so audio input. So she's got inputs that completely surround her in this sort of virtual world. But really importantly, you'll notice she's not just sitting on a couch, she's not just passive, she's moving around. And actually, one of the most important things about VR is that you interact with VR using your body through your own movements. You kind of pick things up. You turn your head around to look around. It's not like a screen where you're sort of explicitly navigating. So VR is very much about the displays, but it's also about tracking people's behavior. And we'll come back to that in a bit. And VR is also about illusions. So we have the illusion of being in another place called place illusion. And really, I won't go into much detail, but this is created by the fact that you can move around. You move around with your head. Everything responds to your movement as if it was the real world. You also have plausibility illusion, that what's happening is real. And this is really about the world responding to you as you're expecting it to. So this is about realistic behavior. And a lot of that is what I'm going to talk about today. And we have embodiment illusion, that you have a body in VR. So as I said, you're really interacting with your body. Not something I'm going to talk about so much today. So in terms of technology, this is what we're looking at. Up till a couple of years ago, we had the Oculus Rift and the HTC Vive launched in 2017, I believe. These lovely high-end headsets with hand trackers, with tracking systems, but they were pretty expensive. And what's more, you need a really, really expensive PC to run them. What's happened in the last year or so is that we've had new headsets launched, and one in particular, the Oculus Quest in the bottom left-hand corner, is that's standalone. You don't need an expensive PC, so that's $400, which but you just buy it and you have everything. It's ready to go, and I think this is a real game changer that's going to make VR a lot bigger. Unfortunately, it's a perfect thing to have in lockdown, but it's completely sold out. So at the moment, the thing that's holding VR up is really the ability to produce these headsets at scale. So that's a little intro to VR. You can always ask me some more questions. Someone's asking if it will be available on the video after the live stream. Yes, it will be. Um, so, what is AI? Well, in this talk, I use AI to really mean a technology called machine learning, and that's what it generally means to a lot of the sort of the big hype about AI at the moment is about machine learning. So, what is machine learning? Well, let's take an example. How would you program a computer to tell the difference between a cat and a dog, for example, from pictures? Well, that's actually really quite difficult. What is the difference between a cat and a dog? There are lots of tiny little features, but could you really work out a set of rules that's saying, exactly this shape of nose is a cat, that shape of nose is a dog? How would you program it? It's an incredibly hard task, and we've been very successful at it. Instead, how about if we start with lots of examples? We start with lots of pictures of cats and lots of pictures of dogs. And, that's in a sense, as human beings, that's how we would learn the difference between cats and dogs, is just by looking at lots of them. And machine learning is a technology that can use all these examples to learn how to do a task, like telling the difference between cats and dogs, from a whole load of examples. So how does it work? Well, what machine learning does is it learns a model. What's a model? A model is something that just takes an input and gives an output. I mean, that sounds like very general computing. So an input might be a picture. And the output might be to say, is this a cat or a dog? In this case, this is a cat. So that's, many computer systems look a bit like that. The clever thing about machine learning is that you start with a bunch of examples. So you might start with a load of pictures of cats, and each of them is labeled. It says, this is a picture of a cat. And a load of pictures of dogs, and each one says, this is a picture of a dog. And then you feed it into a learning algorithm. Now, what the learning algorithm does is it does a lot of statistical maths, and it comes up with this mathematical model where you input a picture and you output whether it's a cat and a dog. So that's the real clever bit. And I won't go into detail about how that works, but it's very clever. And at the end of it, you can put a picture into your input and it will tell you if it's a cat and a dog. So that's the general idea of what machine learning is. And that's kind of how I'm going to, refer to AI for this talk. So what I want to look at for this talk is I'm going to give 3 examples of how we might use AI technology to make better VR. And I'm going to go through these one by one. And they're all, they're mostly ones that either I work on or we work on in some way at Goldsmiths. So let's look at this first. So content generation. So VR experiences need what we'd say are content. So that means, the places, the environments, the objects, the characters that make up the VR world. So it's very much like, a game, similar in game engines. You need places content. And most of the time, this content is made by hand by human beings. It's hand designed. But increasingly we're looking at sort of environments where this is generated by computers. Now, a really good example of, a procedurally generated game is Minecraft. So Minecraft, all the environments are created, by a computer algorithm. It's not the kind of machine learning AI I'm talking about, but it is a computer algorithm. But there's lots of more complex stuff. So this is some work by Professor at Goldsmiths, William Latham, who uses complex genetic algorithms to create these kind of very sort of surreal, biologically inspired VR environments. And this is some work that a PhD student of mine, Sokol Morituri, is working on at the moment to generate game environments procedurally using machine learning algorithms. So this is one aspect of how you might use AI, is to generate the environments, to create the environments without human input. So you might take a bunch of examples, and in this case, you might have some very simplified, like schematic drawings of what the environment should look like. That might be your input, and your output is the complex full environment. And then you can put in new inputs and generate new sort of environments and levels. And what this gives you is, well, it might save some time for the content creators, so it might enable a small studio to create a huge VR environment, but it's also a way of generating bespoke content for each individual player or time you go in. So that's that's what Minecraft does. You can create your own world because those worlds are procedurally generated. So so that's one example. Let's look at another example. Now, I said earlier that VR isn't just about like watching stuff. It's not just about displays. It's about interacting with the world with your movements. But human movement is very complex. So we can use artificial intelligence to better understand how we move, so as to better create embodied interaction. So we saw sort of Christina interacting in a complicated way, and these are some examples of work. So I've got the guy in the blue t-shirt, that's playing a game. You're interacting with your body. The guy in the tank top it's a gestural interaction system. We're recognizing his gestures to interact with a VR archaeological environment, and there's a dancer in the end. Dancers' movements are incredibly complicated, so it's very hard to write programs to explicitly describe a particular movement. So the thing about a lot of the way we move and interact with the world is we know how to move. We know how to pick things up. We know how to dance. We know how to do all these things, to gesture. But we just do a lot of it subconsciously. We don't think about, how to do it. We just do it. And what that means is that we don't really know, we can't really come up with a set of rules. It's incredibly difficult to come up with a set of rules of, this is my angry gesture, or this is my dance move. Trying to turn that into code is either going to be impossible, or you're going to have to really simplify what the movements are. So instead, we can use machine learning AI to learn to recognize these complex models. Just as we recognize the difference between a cat and a dog, two very complex concepts, we can recognize the difference between two different types of gestures or two different dance moves. So, let's have a look at how we might do that. Here again, we're going to look at lots of different examples of movement. So the input here is movement. Now, there's lots of ways of sensing movement, but I generally work with some form of motion capture. So this is a device where you kind of have sensors on the body and you can track the movements. But the great thing is that modern VR devices do have a certain sort of motion capture. So you have two hand trackers, two controllers which track your movements, and a head controller which tracks your movements. It's only 3 points in the body, but it's really, you can get quite a lot of movement out of that. And then once you have that, you can get new input, and as usual, as I usually say, you get a movement out of that. Oh, I'm just seeing I'm blocking. That says punch. The output of the model is punch. So that's the general idea, and what that does is it lets you create movements that are really that you couldn't do, that are too complex to recognize with simple code. And I think this is a quote from a colleague of mine at Goldsmiths, Rebecca Feebrink, actually from a study she did with musicians using this kind of approach to create movement-based musical instruments. And one of the musicians she was working with said this: it's the Wekinator, which is her software, her machine learning software, emphasizing an embodied approach to composition by allowing you to generate training examples by actually performing gestures in real time. So you're actually doing the movements as opposed to the mapping creation process rationally or mathematically, as is required in the design of explicit function models. So a lot of these electronic musicians are having to like explicitly program stuff, come up with like mathematical formulae for a gesture, but that gestures don't really work like that. We don't think of our gestures mathematically. We just do them. And what machine learning does is it lets you design these movement-based interactions just by doing them. And we've got a major project funded by EPSRC, Engineering Physical Council Research Council, which is looking at just that. How do you use AI to use movement as a design tool? Okay, so that's another example. Just seeing if what's going on in the chat. Okay, some people people are chatting away. Brilliant, talking about procedural content generation. What level of math is required for AI? So what I'm doing is trying to build AI platforms where you can train machine learning algorithms without using a lot of math. So I'm building platforms for non-experts. But if you want to go and specialize in it, it is quite a mathematical field. So you do need to know your maths, but in a way, actually, the maths you need isn't that much more than just high school maths. It's kind of linear algebra, vector spaces, and a tiny bit of calculus. Nothing terribly much so advanced, but you do need to like be on top of that. So it tends to be quite a mathematical approach. Though in some ways it varies between whether you're doing, if you're really the person designing the algorithms and proving they work, you need to be really good at maths, but you can also go through, do machine learning work that is more applied, which, you're maybe using existing libraries, which is a little bit less so. But it does help to have a really, really strong foundation of like high school plus maybe first year undergraduate maths. Okay, yeah, calculus and vectors. That's a good way of putting it. So next up, the final example, which in many ways is what I have done most of my work on. So that is virtual humans. So these are creating characters for VR and making them feel real. And in a sense, this is an obvious way of saying, what AI means. Like you're actually trying to recreate humans. So this is an example of a character I used ages ago. This is a virtual version of Sylvia Pan, my long-term collaborator and also lecturer at Goldsmiths. This is some work she did in using characters for medical training. So you as a doctor in VR having to learn how to interact with patients who are maybe a bit challenging to work with. And this is another example of somebody in VR. It's actually the same archaeologist I worked with in Italy a few years ago, interacting with a virtual character. And this is, to make this point, is I'm really looking at, not just characters on screen, but looking at virtual characters that you can interact with life size, just as you would interact with a real human in VR. So that's one of our major challenges. If you're interested, this is actually using a cave-like system. It's a bit different from the head-mounted displays you would typically use in VR. What it does is it has projected screens, but it still completely surrounds you, and it's still 3D, and it still follows your movements, just as a head-mounted display does. It's a lot easier to take nice-looking photographs of it, though. So the general idea is how do you create characters that respond to you realistically? And there's a big problem, a big challenge there in terms of language. How do you get characters that respond to you, that can respond realistically to what you say? And that's very much like the sort of the Amazon Alexa or the Apple Siri kind of situation. This kind of agent that is understands language and is able to respond. That's not actually what I personally work on, because I think there's another thing which, when it comes to VR, that's also really important. That makes a big difference in VR. I can have a conversation with Alexa or Siri that feels a little bit like a phone conversation. I might have with someone, but there's a difference between being there live with somebody. And if we go back to this slide, you're seeing that you're live there in front of somebody life size, and that feels different. It just does feel different. And I think we're realizing this a lot now that we're all locked down and we're not seeing people so much, and we're seeing people via these sort of limited video links. And I think one of the big differences there is that you're not getting that full body language. Sure, you can see my body language. You can see my gestures. I'm gesturing a lot, but I can't make eye contact with you. I mean, I can kind of look at the camera, and that looks a bit like I'm making eye contact with you. It's a bit annoying because actually that means I'm not looking at my screen and all my slides. And if we were doing a live video, if I thought I was looking at your eyes, I wouldn't be looking at your eyes. So that kind of doesn't work in lots of levels. And you're just not in the same space as me. Whereas if I'm in VR, I can be in the same space as another person. I could gesture towards you. I can make eye contact. I can turn my head away from you or towards another person, and that can feel a lot more real. At the moment, you're losing a lot of the facial expressions, but my experience now, and I'm doing a lot more social VR as well for obvious reasons, is that it feels very, very different, and it feels different because we can stand around chatting in quite a natural way. I can turn to somebody, I can wave at somebody, and I can use my body in that way, which feels much more like a normal interaction. Now, I've been trying to do that with virtual characters, and really with virtual characters, all of this, is everything I've said so far is even more true. They need to be able to recognize what we're doing. So body language isn't just a one-way thing. I would respond to your body language in real time if I was talking to you live, and you would respond to me. So you need to be able to understand what the other person is doing and respond. And everything I've said about movements not being, us not knowing how we do our movements, but just doing it, applies doubly, triply to body language. It's an ultimate example of something we're doing all the time, but we're not aware of, and that means we don't know how to create it. And in particular, even the sort of the most cutting-edge social neuroscientists, psychologists who I'm working with at the moment, but they don't have a full theory of how our body language works. So it's a very difficult thing. So it's exactly the sort of thing that you can't program explicitly. You have to use something like machine learning. So how does this work? So this is an example. This is actually a really old diagram, but it kind of applies to a lot of the work that we've been doing over the years. So I start off by having two people interact in a social situation. So get two people to have a conversation of some sort. And this is an example of some work we're doing recently with the Institute of Cognitive Neuroscience, Antonia Hamilton at University College London, of recording really rich data about a conversation. So we can see here we're recording their facial expressions, we're motion capturing, getting their body movements, we're recording their audio, what they're saying, just with an ordinary microphone, and they have, you can't really see, but they've got eye tracking glasses on, so you can see where they're looking. So we record data of their movements, and what we do is we synchronize those movements. So we put them together so that we know what one person is doing while the other is talking, for example. Just checking. Might be having a slight issue. Okay. I just paused there for a minute. Hope that was okay. I was getting a bit of an error from YouTube. So hopefully I didn't cut out there. Shout in the stream if you missed anything. So Anyway, just to summarize, so we're capturing movements of two people. We're recording their data, synchronizing that so that we know how those two people are interacting. And then we use a machine learning model to learn how they interact, so that we learn how the behavior of one person influences the behavior of the other person. That's exactly what we need for this kind of character interaction, is that we learn how one person responds to the other, and machine learning algorithms can do that. Now, in this particular diagram, I'm using sort of, very kind of old models of that. That doesn't matter too much. It's what the machine learning algorithms. I've kind of done this kind of thing over many years, and so have collaborators of mine. So in those days, I used something, and this would have been 2008. I used something called a dynamic Bayesian network, which is a very exciting thing at the time. Now we've got other collaborators like Christina, who I mentioned earlier, who's working with deep neural networks, which are the thing that's really exciting right now. So what does this do? I'm going to show you a little video of something I created a while ago. So this is learned from a person, an actor responding to some audio, somebody speaking.
For example, if I were to
so this is responding in real time to the voice. This isn't recorded. This is a new piece of audio.
They would show this boredom by becoming distracted.
It responds to the tone of voice, and you can see as it gets more boring, the character gets more bored.
This type of responsiveness is central to human social
And then, as it gets interesting again, the tone gets more varied, the character gets more engaged. So this was using very, very, very simple
to produce responsive behavior to user inputs.
algorithms for recording audio. It wasn't anything very sophisticated. The machine learning algorithm was quite sophisticated. Even that wasn't particularly sophisticated at the time. But we've been working with this kind of approach since then to develop more interesting ways of doing it. So, for example, the latest piece of work we've been working on is some of you might recognise this if you're in the UK. We've been working on a video game based on the TV series Peaky Blinders, together with games companies called Maze Theory and Dream Reality Interactive. So that's with Sylvia Pan and Christina Dobre, who both seem to be on the live stream. So that's great. They can say hello, and you can ask them questions about it. But this is an example. This is one of the great things about sort of research. So I'm doing this sort of research, or we were, it's not just me. Our group was doing this research, 12, 15 years ago. And it was like, this is crazy way out stuff. Who would ever use this? And, nobody has a VR headset. The AI, the machine learning is too computationally expensive, But, I had this idea. I think this could do something exciting. And, a decade and a half later, actually, it's time to use it. Actually, it's a moment where this can be started to roll out into the production process of games companies, and it's not out yet, but hopefully in the next year or so it'll be in a fully live rolled out game, which will be really, really exciting and become the state of the art. So that's one of the exciting things about working in a research university, really, is that you're working on research projects that really push the boundary, and might not be ready yet, but you'll see in a few years' time can become the new hot thing, and you'll be working on them before you get there. So that's mostly what I've been saying. I'm happy to take questions from the chat. I've seen there's lots of chatting going on. I've been talking, so I haven't really followed that chat. So I'm going to just make talk about a couple of other things we're doing. So many of you I know are studying with us, but if you're not studying with us and you want to find out more about our VR work, we've got a MOOC. That's a massively open online course. It's been around for a couple of years. on virtual reality with Sylvia Pan and myself. That gives you a good overview of VR in general. I also have a little one about AI. And also we have a master's program in virtual and augmented reality that's, where, as well as general VR and AI, you'll learn about some of the things I've been talking about here today. So, and, as you would if you did one of our undergraduate courses in, for example, computer science or games development. And all of these things will be both on the on-campus courses and the online courses. So I'm going to have a look at the chat stream. I've seen that, as I said, there's lots going. Okay, do frame rates play a role in VR? I know they do in normal interaction. Yes, very heavily so. You have to have a very high frame rate in VR because if the frame rate starts to get a bit low, you can start to feel sick. So, because it's taking over your entire perceptual apparatus in a way, you can't, if something goes wrong, if the world slows down, then rather than feeling like there's a monitor that's going slow, it's like the entire world is slowing down. Your perceptual system starts to think something's really wrong, and then that can make you feel sick. So somebody's asking about projects online in online learning. So we do a lot of project work in online learning. Now I think we have people doing really great projects. What you don't get so much is the ability to sort of sit down with us in person and like really work out any problems that you have. That's what you really get from being on campus. But so you have to be a bit more of an independent learner and an independent problem solver. But if you're able to do that, and there's still a lot of online help in online programs. So yes, you can do some really great great project work online. Ask me some questions. It looks like all the questions are being answered by my colleagues. Is VR something to consider if you're studying both computer science and psychology A level? Yes, absolutely. I haven't really talked about that, but I've kind of mentioned that I'm working with psychologists, but it's a really psychology of the medium is really important. VR combines both technology, psychology, and also creative work. It's a very interdisciplinary field, and that's what makes it exciting for me. It's not just like straight down the line computer science. It brings in lots of different subject areas. I'm a prospective software engineer, but I'm wondering whether there'll even be a job for me in 10 years. Then it might be AI doing it all for me. I think there'll still be a job. So, you get a lot of hype about AI and it's doing some really, really amazing stuff, but it is only able to do certain things. And I think, the current wave of AI is only going to be able to tackle certain problems, and there's still going to be other challenging things that you'll need other skills for. But if you're looking into software engineering, getting to know a bit of AI programming is a useful thing to learn. Do I have to be a computer science student in 12th? I assume that means year 12 to do a BSc in computer science. No, we will accept students who aren't doing A-level or high school computer science. We normally ask for some maths, but we're actually looking for students coming with lots of different backgrounds because historically, there hasn't been much computer science in high school. So, historically we haven't needed that or we haven't required it. And, we really do start things from the beginning. And, other areas of expertise are really valuable for computing studies. Okay. Okay. How do I zoom down? Someone asking if we can apply AI in biology, absolutely, it's used very much in biology. So there's lots of really complex problems with a lot of data. So in machine learning, you're training from example data, you need a lot of data, and it's for things that it's very hard to program explicitly, like the really complex interactions that happen within cells or within proteins. So yeah, it's very, very heavily used in biology. Of the kind of scientific subjects, that's probably where it's used most. Um, Someone can from Kenya, Edward, considering an online course in computer science. What are the pros and cons? So the pros are really that you can study, world class degrees anywhere in the world. You can study with us from Kenya. You don't have to travel to London. Um, that makes it, in some ways a lot cheaper. Another big benefit, and most people studying our online degrees we find is that they're actually people who are working full time, so or like at least part time. So you can carry on with the rest of your life with your work commitments, your family commitments, while you study at the same time, and that's really really important to a lot of people. Like a lot of our students are a little bit older. They've, they're already through life. They might already have a family. They might already have a good job that they don't want to quit, but they want to get that study, and that's one of the big benefits of online learning. Is its flexibility. So it's all we have videos, we have activities, but you can do it all in your own time. There's very little of live. You have to be here in this exact moment kind of teaching. So it's that kind of flexible learning that fits around your life, and you can study it anywhere in the world. Those big advantages. The thing I will say, I mentioned a little bit earlier, you do need probably to be a little bit more of an independent learner. You because you're doing it in your own time, because you're not doing it with a teacher like us in the room. You need to be able to motivate yourself and get on yourself. That doesn't mean you don't get support. Absolutely, you have tutors, you can ask questions, but you're a little bit you're a bit more on your own. So it is good for independent learners. So VR is often mentioned with AR. Do we have modules in AR? Yes, these are connected media. So virtual reality is about completely surrounding you. So the goggles block out the real world. Augmented reality is about mixing the real and virtual world, and you can sort of see that in two ways. One of this is with a phone, so you can like pick up your phone and you can look through your phone, and you can see virtual stuff like virtual people or virtual objects in the real world. Or more excitingly, you can put on goggles like the VR goggles, and you can see both the real world and it's completely immersive. You're just wearing them like sunglasses and you can see the virtual world and the virtual objects in the real world. I mean, so that's a really exciting prospect. It's a bit different for VR. The what I call the immersive, the goggles based AR, there are prototypes out now. You can buy really high end systems, but it's probably not there yet in terms of like consumer level. But I would say they're both really exciting media. They both use a lot of the same technologies. A lot of the same people are interested in them. I think they'll have slightly different uses. I mean, I think not everybody would agree with me, but I think sort of for fiction, for like stories, I think VR is much better because I don't want like if I don't want sort of to see Game of Thrones like Jon Snow in my kitchen. I want to go to Westeros. I want to experience everything. So that's and it's in this kind of lockdown situation where you want to get out. You want to go to another place. You want to go and meet people together in another place. But AR is much better when we're all together again and we're meeting in person. If we, then it's much better to have augmented reality because you can just see other people. You don't have to have any mediation. They're just right in front of you, but you can have virtual stuff there as well. And also, there's lots of kind of work and work related stuff where AR might be really useful to have stuff embedded in the real world. So they're both really interesting media. I think they'll be useful for different things, but they're going to evolve together. It's a lot of the same people doing it. And somebody asked about mixed reality. Mixed realities. What that means is that there's at one end you have they're not completely distinct. You can have kind of things in the middle which are more virtual and more real, and sort of, so that's kind of saying it's a slider. And I think in a certain sense, I hope that maybe you'll get a single headset that does both, and you can sort of vary between one and the other. What are the requirements to do the CS course on Coursera? I can post those. They're quite complicated because people are applying from all over the world. What's my opinion of the future of VR? It's been out for quite a long time, and it's not as popular as it could be. So really, I think that there's a few reasons for that, and I'm going to go back to one of my early slides. So first off, at launch, these systems were really expensive. Not necessarily because the thing themselves are expensive. They're kind of like a console. But you had to have a really high-end PC to use them. Whereas now something like the Oculus Quest, it's £400 for a single item. It's kind of like a games console. It's not wildly expensive to get. So I think it's becoming more popular. One of the reasons right now in lockdown is not more popular than it is because it's completely sold out. So it's very popular, but it's you just can't get one. Which is really unfortunate, and makes life difficult for us. But also another thing as well is that I think we're used to technologies being adopted very, very quickly because we're used to smartphone and apps. So if you've got an app, people could download that tomorrow, and it costs nothing, and you can get millions of people using it in a few weeks. Even with a phone, like when the iPhone came out, it was, everybody already had a mobile phone, and it was a case of, when I upgrade my, Nokia phone, I can get an iPhone, or I can get an Android phone. So it was much more natural. So I think adoption will take longer if you're asking people to buy a completely new device. So I'm not sort of, the trouble right now is we have this like super hype. Everybody's going to be using VR in 2 years' time, and it's going to take over the world. That is not very realistic. It will take time because people have to buy a new piece of kit, and not everybody. It takes a while for everybody to realize how exciting that kit is or why they would want it. So I think it will. We are seeing a gradual adoption of by people, early adopters, and now sort of second wave adopters who are really realizing it. And it will be a little bit slow. I mean, but right now it's just simply slow because they're not able to keep up with demand. The producers are not able to keep up with demand. I think you'd have a lot more people using VR in lockdown if they were able to get hold of headsets. Okay, lots of people. Okay, I think someone's asked about just degree apprenticeships. Fortunately, we don't have degree apprenticeships. I think we've been about 45 minutes. So unless there's any final questions in there, I'm going to stop the stream. Oh, okay. I'll take Augustine's question. Is an online degree in CS okay for starting a career in research? Yes. So certainly I don't know all the online degrees, but our online degree in terms of content, in terms of rigor, is, it's not exactly the same, but is of the same quality and covers the same basic topics as our on campus. So you can certainly do a master's or a PhD coming out of our on-campus degree. I keep name checking Christina, but she was an undergraduate student at Goldsmiths and is now doing a PhD with us. Same goes for an online degree. So our current online degree is very new, but we had a previous distance learning degree. Well, it still exists actually, and someone came from that degree, a guy called Mohammed Al-Rafai, who then came to Goldsmiths in person to do a PhD, then became a lecturer, is now a researcher and lecturer at University of Greenwich, has some fantastic research publications in biologically inspired computing. So absolutely good for research. I forgot your other question. How necessary are low-level languages and logic? We teach a little bit of low-level languages, but certainly in both our online and our on-campus courses, the lowest level language you'll use regularly is C++ and C. So, I think for a variety of reasons, kind of like assembly languages are not so used anymore. Part of that is because there's so many good high-level languages and you don't need that extra speed up. And part of it is because chips have become so much more complicated that, they're no longer designed for people to be able to effectively program them by hands. The machine languages have to become a lot more complex. So often actually just using a good compiler for C will produce better machine language than hard coding it. It's faster even. Okay, so I think we've been on here for 50 minutes, so I think I'm just going to say a big thank you to everybody who's taken part. It's wonderful to hear from you all from all over the world. It's wonderful to hear from people who are hopefully going to be studying with us, and I really look forward to seeing you. And those of you who are already studying with us, really good to have you together. So it's really great, and I really hope I've got you interested in virtual reality and artificial intelligence. Certainly things I'm really excited about, and hopefully you will be too. And maybe we'll see you in a master's program talking about them now. So thanks again, everybody. Thank you for attending our first ever Goldsmiths Computing Lockdown lecture. Next week, we are having a lecture from the hilarious Sarah Wiseman. She's a really fantastic computer scientist, but believe me, she's also very funny and will give a great presentation. She's talking about the culture of emojis and what that means. So I'm sure I will learn a lot from that as well as you will. So hopefully I'll see you there next week. So have a great week, keep safe, and hope you're all doing well in lockdown.